All right. Hello, statistics students. Welcome into section 6.1, 6.2, where we're going to be talking about the standard normal curve. This is the start of our last chapter here that we're going to cover in this class. We've got a ton going on here, but most of the stuff is actually going to be review. We're going to talk about the normal curve, which is something we actually covered in section 2.6. You should already know what this is. But we're going to review it because it has been a minute here. Then we'll talk about probability distributions for continuous random variables. Talking about percentage, proportion, and probability, and then finding the area of under the normal curve, left of a z-score, right of a z-score, and then in between two z-scores, and then we'll go backwards, finding the z-score given the area to the left, the right, and in the bounded area. Just a heads up, you're definitely, for all these sections here, you're definitely going to want your Inspire, please. I know I've joked in the past, but really, this whole chapter, you're really going to want your Inspire because it's going to make your life really, 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 really easy. Okay, let's start. So we're reviewing the normal curve first, okay? So a friendly reminder that a normal curve is the shape of a normal distribution. And when we're talking about here, okay, whenever X bar is the center, remember this is the universal symbol when we're talking in stats for a sample mean. And then S is the spread, and that is known as the sample distribution, the sample standard deviation. All right, we can take any distribution and represent it as a normal curve if we know the sample mean and the sample standard deviation. And then we have the general normal curve, which is converted using z-scores. Remember the bottom here is standard scores, okay? This is the representation of the entire parameter, all right, which represents the entire population. So remember, we can always represent normal curves with an n, comma, and then parentheses, where this first number is the mean and the second number is the standard deviation. But since we're getting into a little bit of a higher level statistics here, now we're gonna use the correct symbols here. So a standard normal curve is represented with an n and then comma with the parameter symbol for mean, which is mu, and then the parameter symbol for standard deviation, which is sigma. Okay. Remember, this is for population mean, and sigma is known as the population standard deviation. Let's put SD for short. Okay, remember, sample is based off your sample, population has that. So we have this normal curve, and the only thing that you have to remember too is that we talked about is the empirical rule, which states that 68% of the data lies between one standard deviation, so that here is 68 right here. So 68% of the data is going to represent between one standard deviation, so one standard deviation. 95% of the data is going to lie between two standard deviations. And then lastly, 99.7% of the data is going to last between three. So I'm going to kind of cut off this graph a little bit, but so you can remember to get visual here. All right. Which means that 0.03% of the data is beyond three standard deviations, but yeah, that's important to remember that rule. All right. Okay. So let's continue. So really quickly, just going to kind of talk about this. So probability distributions for random variables. So what you see here, this f of x function that is crazy, and you're probably freaking like, oh my God. This just represents the curve of a normal curve. So if you're looking at this picture here, this function represents the red curve here, right? The red curve that we know, where all these at the bottom here, like I just said, are z-scores. But remember, there is a formula for z-score, but I don't know if you can see it. It's actually right here. There's your z-score, how to calculate a z-score, whatever value you're trying to find, subtract the mean, divide by the standard deviation. This is not a formula you're going to need to know. Go from there. But I just wanted to show you, like, hey, the stuff we're dealing with, we're starting to get into more complicated stat stuff. So just want to see where this normal curve comes. It's called the Gaussian curve equation. But again, not something good. This formula, however, is something that we're going to be doing a lot. This is how to calculate a continuous probability using standard deviations and means. Now, the beauty of it. Good news and bad news. Good news, you don't need to know this. Bad news, we are going to be using it. But as all things, you have a calculator function that actually will do this for you. Obviously, if you don't know what this is an integral. This is from calculus. No, I don't expect you to be doing any calculus in here. However, the calculator function that you're going to need to know, maybe write this down, is going to be menu. Oops. Your teacher can't spell menu. Menu 552. And we'll talk about what that's going to be. It's called norm CDF. That's what we're going to need, okay? All right, so what this actually does is, for those of you who don't know what integrals are, integrals help us find area under a curve. In the past, you've been estimating using the empirical rule, right? If I ask you, hey, find the area of less than z-score is 0, you would just add 34.13, 13.59, 2.14, and 0.15. It's doable if I just give you the whole numbers. What if I ask you, well, what's the z-score less than, I don't know, negative 1.5, which is actually going to be our first one. We would have to use this, but we're not going to use this. We're going to use the calculator function. All right, let's start off. So first off, just a quick thing. This is actually from the textbook here. Percentage, proportion, and probabilities here. So a proportion is usually represented by a fraction. 1/4 of the people are sick. So this is where we read it as a fraction, right? A percentage of people is used when talking about a proportion of the population. 25% of the population is sick. And then the probability is usually used when talking about the chance of an event occurring. The probability of getting sick is 0.25. All right. So I know a lot of questions, like, I've gotten on tests and quizzes like, hey, Mr. K, do I use a fraction? Do I use a percentage? Or do I use a proportion? Honestly, I haven't been too picky about it in this class, but your book really likes here finally, since we've really talked about all these things, is when do I use what? Well, this is a good rule to stick by. So maybe writing this down or taking a picture of this might be helpful. When to use what. Again, I'm going to continue to not be picky, but go from there. Whatever makes your life easy. All right. So let's try the areas left of the z-score. All right. So like I said, all right, we are going to be doing this with the standard normal curve. All right. So for all of these, assume your mean is 0 and your standard deviation is 1, and the bottom here are representative z-scores. Okay. So let's go ahead and find this. So we want to find the probability of a z-score is less than negative 1.5. So again, from here, you need your calculator. So if we want to find some z-scores here, so what we need to do is we need to find what they're essentially asking us is, hey, given this curve, I want to find the area of a z-score less than. So I want to find this area right here. And keep in mind, yes, it looks like this touches the x-axis here, but this curve is never ending, all right, which is going to be an important thing to understand, all right, but we're trying to find this area right here, anything left of a z-score of negative 1.5. So here's what we're going to do. We're going to use this calculator function, which I told you again is menu 552, okay? So let me bring my calculator up, okay? We're going to go menu 552. Which is norm CDF, okay? Now, you're going to be asked 4 values: a lower bound, an upper bound, a mu value, which is your mean, and a sigma value, which is your standard deviation. Keep these alone, okay? You can do normal CDF with other than the standard normal curve. You just have to change these. However, we're just practicing with the standard normal curve, so we're going to leave this alone. Okay. In this case, if I come back to the slideshow, right, we want the area left. Okay, and like I told you, this curve never ends. So we basically want a big number here that defaults to infinity. And the way that is in your calculator, you kind of know, by saw it's already preset for you. You're going to write negative 9 e 999. That's the lower bound. This is negative 9 times 10 to the 999th power, which is a very big number. This will cover everything to the left of that curve. Okay, that's your lower bound. All right, our upper bound is our z-score, which is negative 1.5. And then your next two would be your mean, and then your standard deviation, which we're going to leave alone. So if I come here, okay, nice thing is the calculator does default to negative 9e999, because if you remember in the function, for those of you that know calculus here, let me go one more. this integral, this is your lower bound, negative infinity right here, okay? Not that if you don't know calculus and you don't know what I'm talking about, ignore that part. But if you are taking calc currently, you'll know what that means. Anyway, so we got this. So this is what as far as work, what I want to see is this is what I want to see. I want to see the norm CDF, all four lowers, just like when we did binomial distributions, right? But the rest, let's just go ahead and go back to my calculator, and let's type that in. So that's going to be negative 1.5 is our upper bound, and we'll leave those two alone. And it spits out 0.066807, rounding to 3 decimal places, that's 0.067, or in other words, 6.7%. Okay, just know that in CCP stats, we call this a p-value. Okay, so the probability of a z-score being less than negative 1.5 is going to be 0.067 or 6.7%. Okay, so let's practice a few more here. All right, so now I want the probability of a z-score being less than 2. So again, that is all of this whole area here. Now, again, you could have done this one before. All right, you could have done this using the jumped off sections in chapter 2, but now you have a calculator command that's going to be really, really nice. Okay, again, the 4 values. So your lower bound, once again, is going to be this negative 9, E999. Our upper bound is 2, and then we're going to go 0 and 1. Once again, we are changing that. So if I come back to my calculator here, let's do it again. Menu 552. Our upper bound is 2 now. Keep that the same. And looks like we got, ooh, that's a big one. 0.977 or 97.7%. So we'll come back here. That is going to equal, so I'll do it right. Probability of a z-score less than 2 equals 0.977. Okay. All right, moving right on along. All right, now let's find the area to the right of a z-score, right? So now here's what we're gonna do. All right, so now I want to find the area that the probability that a z-score is greater than negative 0.83. So now I want this area right here, okay? And please excuse my coloring, I don't feel like changing it in. All right, now here's what I'm gonna put in. So it's the same calculator command, but now my lower bound is gonna be that z-score. So we got negative 0.83 is our lower bound. Now, what are we going to do for the upper bound? Again, the curve continues on and on forever like this, right? You got to represent it. So it's going to be a very simple thing. Instead of negative 9, E99, we're going to put positive 9, E99, and then 0 for mean, 1 for standard deviation. The probability of a z-score is greater than negative 0.83. If you hear anything, my cats are fighting. Please ignore them. Anyway, so we'll go menu 552. All right, now our lower bound is negative 0.83. Hold on. Did I go from here? Yeah, negative 0.83. All right, our upper bound is going to be 9E999. It shouldn't, don't worry about, if we calculate that, 011. Variable not defined. Okay, oh, you know what? It's because I used a lowercase e. Okay, so your calculator is sensitive. All right, let's try it again. So we're going to go 0.83. Negative 0.83. Zero one. That's it. Okay, hold up. I'm gonna pause it real quick and figure out why this is acting dumb. Okay, I got it. Your math teacher is not smart. Well, yeah. Anyway, let's try this again. Menu 552. All right, so it is negative 0.83. Okay. Now, when you do the E, we're going to type 9, and then we need the E. You need this little double E here That's right above the pi menu symbol, right next to the A here. I'm sorry, I forgot about that. You have to do it. It's been forever since I used this function. But yeah, you have to use that one. If you just use a regular E, it's going to treat that E as a variable, which is why it was yelling at me. 999, keep that simple. Okay, now we're in business. All right, that is 0.796, so we'll round that up. So 0.797. 0.797 or 79.7%. All right, and now to find a z-score of greater than 2.21, so we're finding this little area here. All right, this would be probability of a z-score being greater than 2.21 equals norm CDF. That is going to be 2.21 as our lower bound, and then 9E 999 0, 1. So menu 552. Oops. 55. Oops. So we're going to go 2.21. 9. Make sure you hit this lower E right here. 999 0, 1. And we get 0.013, 0.01 rounding up 4. So about 1.4%. So 0.0. Remember, the big thing I care about, what I'm going to be checking, I just need to see norm CDF. I need to see all 4 inputs. I need to see what you're putting into the calculator. Okay, moving on. I will probably cut that out of me screwing up in the calculator just to save time on the puzzle. But okay. All right. Now what we're going to do is we're going to find, oh, never mind. We're not going to do anything. You're going to do something, and you're going to find the area to the left of a z-score of 0.9. This is your first step puzzle question. Good luck. All right. Let's go ahead and do this real quick to test your answer. So again, we want the z-score less than this, so we want this area. So you should have put it in your calculator, negative 9E999. Comma 0.9, and then 0, 1. So we'll do that in your calculator real quickly. Menu 552. All right, we wanted 0.9 and go. You should have gotten a z-score of 0.815, rounding up, so 0.816. So your answer should have been 0.816. All right, moving right along. So now let's go ahead and talk about how to find the area in between two z-scores. So this should be a pretty basic, all right? So now we're going to do none of those, So again, the nice thing is now you have a lower bound and an upper bound. You don't got to worry about infinity or exponents to the 99th power or whatever, all right? So if we want to find a z-score in between two values, we're just going to do this, all right? So we want to find the area in between all of this, the area underneath the curve, right? This is what you're going to do. You're going to do norm CDF. Your lower bound is going to be negative 2.32. Your upper bound is now going to be 1.6, and we still have a mean of 0 and a standard deviation of 1. So back to your calculator. We're going to go menu 552. All right. So we negative 2.32 to 1.6. And we get 0.935, 93.5%. Okay. Next one, we want to find the area between 0 and 2.10. All right, so that'd be norm CDF, comma 0, 2.1, 0, comma 1. Menu 552, 0, 2.1. And we get 0.482. All right. And that should make sense when you kind of think about it, right? Because we know between 0 and 1 is 34%, right? And then we know roughly that this is 13.5% between 1 and 2. So yeah, 34 plus 13.5 is like 37-ish, right? And then we have this little server. So yeah, this probability makes sense here. Okay, kind of thinking about it from a realist perspective here. Okay, I think it's your turn. Okay, now find the area between negative 1.5 and 1.5. Go ahead and try this now. Okay, I'm going to go ahead. I'm not even going to pause the video here. So this is between negative 1.5. So your calculator command should have been negative 1.5. Norm CDF, negative 1.5 to 1.5, right? And then 0, 1. So we come up and do this here. Menu 552. We got negative 1.5 to 1.5. I'll leave those two alone. Ooh, not 15. That'd be wrong. All right, 0.866. So 0.8. Like that. All right. Okay, so now we're going to talk about how to go backwards. Okay, so if we're looking at this, all right, so now what's being told is now you're given the area. It looks like we're given the area to the left here. So we're given that this area right here is 0.115. But what we want to do is I want the value of the z-score. So the nice little thing is there is another calculator function for this. You don't got to do a bunch of anti-derivatives. Some of you are probably like, what is he talking about? Anyway, so here's how this works, okay? So first off, I'll just show you the calculator, right? So if I come back to your calculator, it is still menu 55. But now we're going to go menu 553 and inverse normal, okay? Now it's going to ask you for three things. It's going to ask you for the area, the mean, and the standard deviation, okay? So these are 0 and 1 as long as you're dealing with a standard normal curve. But this area, okay, we got to be specific here, okay? Your calculator function will always, always, always treat that area input as the area to the left of a z-score. So in this case, we're all good. We have that. So what we're going to do is we're going to do inverse norm 0.115, mean of 0, and a standard deviation of 1. Okay, so if we do that here, 0.115, that's going to give us a z-score of negative 1.2. So the z-score equals negative 1.2. Okie dokie. Okay, and just down here, okay, so now we're given a z-score of, or we're given an area to the left of 0.742. So we're doing inverse norm of 0.742, 0, 1. So menu 553. I already forgotten the area to the left. 0.742. All right. 0, 1. And that's going to be a z-score of 0.64. We'll round that up to 3 decimals. 0.65. 0.65. All right, and that's about right. Okay, but okay, so pretty easy when when you're given the area to the left of the curve, right? What if we're given area to the curve to the right? Okay, so again, this inverse norm function on your TI Inspire will only give you area to the left. So we want to find the z-score with the area given to the right. Well, the nice thing is we know that the total area under the curve is equal to 1, right? Probability rules. So before you do this, you have to find the area to the left. And fortunately, since all probabilities add up to 1 and you're given the area to the right, to find the area to the left, we have to do this. So area to the left equals 1 minus 0.147, which if you put into your calculator is going to give you 0.853. All right, that's this area to the left, which now we'll be able to calculate it. So we're going to go z equals inverse norm 0.853, 0, 1, which can be put into the calculator here. Menu 553, 0.853. That's going to give us a z-score of 1.05, because rounding, right? okay? And same thing down here, we're given the area to the right of 0.971. So I have to find the area to the left by doing 1 minus 0.971, which would be 0.029. Okay, so inverse norm, 0.029, 0, 1. Come back up here. NU 553, 0.029. And that's going to give us a z-score of -1 point, rounding again, -1.9. All right. So remember, when you're given area to the right, your calculator will only treat that as your area input as area to the left. If you put 0.147, the calculator is assuming this area to the left is -1.47, and we can tell that that's definitely not the case here. All right. So make sure you do that little step when you're trying to find when you're given area to the right. If you're given area to the left, just like in this last slide, right, you don't got to do that. But going from there. All right. Here's your puzzle question number 3. Given this area to the right, find the z-score of given an area to the right of 0.37. All right. Just a note before you do this, please stick around. We're going to do a little bit more things, but there's no more puzzle questions. Go ahead. Okay, so looking at this, first thing you should have done since you're given an area to the right, you should have found the area to the left by doing 1 minus 0.37. And that's going to be 0.63. So your inverse norm, 0.63, 0, 1 equals, and if you did it in a calculator, you should have gotten 0.332. So z-score is 0.332. Okay, moving right on along. Let's finish this up. Okay, so like I said, no puzzle question on this, but we are going to do this, okay? What happens if you're given an area in the middle between two z-scores, okay? More specifically, okay, I don't know if you can tell, there's nothing that's given, but you can assume that these z-scores are inverses of each other. What that means is they're the same, just this one's negative, this one is positive, okay? Here's what you do, okay? So first off, we know inverse norm gives us area to the left, right? What I really need here is I just need this area right here, okay? And because if I find this area, I'll be able to get this z-score, and what I can do is I can just make this one positive, right? So let's just say this is like -1.5. This would be +1.5. All I really got to do is I got to find this area, and the way I'm going to do this is, well, since I know the total area under the curve is 1, right? I'm going to subtract 0, whatever this area in the center is. That's going to give me the area of this guy plus the area on the right. I need to divide that by 2, okay? So here's what we're going to do. First thing we're going to do is we're going to take 1 minus 0.95, okay? And divide that by 2. And let's do that. 1 minus 0.95. Oops, 0.95. All right, divide that by 2. Okay, the reason why I have to divide by 2 here is this 0.05 that's the area of this left section and this right section cut off. All right, so what this is now we have 0.025. That's the area to the left of this curve here. Now, okay, what we're going to do is if I double check my notes here. Yep. Now we're going to do inverse norm using this 0.025 because that's the area to the left of the curve. 0, 1. Go ahead and do that. Menu 553, 0.05. And that's going to give us a z-score of -1.96 with rounding. Okay. Which means this guy is -1.96, which makes this guy +1.96. Our two z-scores are -1.96 and +1.96. Okay, last one here. All right, so now we're given that the area in between these two z-scores are 0.55. Again, these two are the same thing. So what we're going to do is 1 minus 0.55. That's going to give us 1 minus 0.55 is going to give us the area in between. Oh, I'm sorry, it's going to give us the area of both of these. But again, I only want this one. I really only care about this one, so I have to divide by 2. So I'm going to divide by 2. And that's going to give us, let's go ahead to our calculator here, 1 minus 0.55, and divide that by 2, 0.225. So we're going to do inverse norm, 0.225, 0, 1. And let's go ahead and do that. While switching back to the calculators here. Okay. Oopsies. I don't want to multiply it by 2. Ignore that. All right. Bring you down. Pretend I didn't type in that. There we go. All right. So negative 0.76. Or I'm sorry. Negative 0.755. Which makes this z-score negative 0.755, and this z-score 0.755. All right, that's it for me. There's no ed puzzle question on this. All right, I'll see you in class where we'll do a Buffon videos, and then we'll do some more practice. All right, as always, email me if you have any questions. I will see you around. Take care, guys.